Okay, this is the solution to E5. E5 gives us data about a function f in the form of a table. And so what they want us at first to do is to estimate f prime of 4, the derivative of f at 4. So we look at the table. This is again the table of f. 4 is not on the table, but 4 lies right in between those two x's, 3 and 5. Those are the two function values associated with 3 and 5 respectively. They want f prime. I hope you're thinking slope here, rise over run, difference in the function values over the difference in x. We'll check the answer in a second, but I think we're pretty happy with how A is going to go. Part B is a little bit more difficult. It's evaluating a definite integral. So the first thing we got to do is think about, well, how do you do a definite integral? How do you evaluate one? Well, we need to find an antiderivative. And once we have the antiderivative of this, then we would plug in 13, then we would plug in 2 after that, and then we would subtract those two results. So the big question is, how do we find the antiderivative of this? Well, it's a difference. So the antiderivative of a difference is the difference of the antiderivatives. The antiderivative of 3 with respect to x is 3x. So we've got that part already done. We know the antiderivative of 3 with respect to x. Now we have to find the antiderivative of 5f prime of x with respect to x. So what we can notice is this is a constant times a function. The antiderivative of a constant times a function is the constant times the antiderivative of the function. So all I need to do is find the antiderivative of f prime, and then I can multiply that by 5. Also notice, I mean, this is a fundamental theorem question as well, if you want to think about it that way. The definite integral of f prime, if you look down here, here are some notes I made. The antiderivative of f prime, how do you find an antiderivative? Or sorry, the definite integral of f prime. How do you find a definite integral? You find an antiderivative. What's the antiderivative of f prime? Why, it's f. So here's just a kind of a side thing. This takes this thing, which is more complicated, and kind of simplifies it down to that part. So if I had this multiplied by 5, and then 3x minus that evaluated at 13 and 2, that would give me the answer. You notice that's what they did. There's the 3. There's 5 times that antiderivative. All right, there's our answer of 8. Part C. Use a left Riemann sum with subintervals indicated by the data to approximate this definite integral. So, left Riemann sum, quite often in class, we would call this a rectangular area sum or a rectangular area measurement. This is also sometimes what we would call LRAM. That's what we want. We want the left rectangular area measurement that approximates this integral. So left means I'm going to use the left boundary to plug into the function to find the heights of each of my rectangles. And then I have to find delta x's of each of these things, and that one too. There's 1, 2, 3, 4 rectangles here. The delta x's would be 3 minus 2 would be the first delta x, 5 minus 3 would be the next one, and so on. So every time, every rectangle is a height, which is, well, f of 2 for the first one, times delta x. Then f of 3, that's the height of the second rectangle, times delta x, and so on until you get to here and stop. Notice you'll never use the rightmost boundary of the interval because you're using the left boundary of each subinterval to find the height of the rectangle. So let's see what work it takes to show your answer here to get credit. let's see what they did. Here are all the heights of the rectangles. Notice they didn't use f of 13. And then their delta x's, 3 minus 2, 5 minus 3, 8 minus 5, 3 minus 2, 5 minus 3, 8 minus 5. Do a whole bunch of arithmetic and you get the answer. Where do the points come in? This first point right here is for writing out the sum, and then that's for doing the arithmetic correctly. By the way, if you look back to part B, here are how the points play out on part B. You have to somehow show that you understand that to find the antiderivative of f prime, you're simply just plugging in values into f. In other words, f is the antiderivative of f prime. An antiderivative. Okay, the last question. There's a lot of information to sort out on the last question. So we're given that f prime at some point is equal to 3. Okay, we'll store that for later. F double prime is negative for every x inside of this interval from 5 to 8. Okay, so what does this mean? This means f is concave down between 5 and 8. Keep that in mind. Use the line tangent to the graph at x equals 5 to show, okay, I don't really understand that yet. Use the secant line to show that. Okay, so something about f of 7, and we have an interval. So I'm going to draw a quick picture here of what I think is going on, and then underneath I've got a more refined picture. But I'm going to start with the idea that f has got to be concave down because f double prime is negative. So between 5 and 8, it's concave down. F is concave down. So f prime of 5 is 3. Here's 5 over here, x equals 5. So I know that f prime is 3 right here, so that means I've got a tangent line right here that's got some kind of positive slope. Okay, that's pretty close to the tangent line. Now what about the secant line business? I've got a secant line that connects 5 and 8 on the graph. Here's 5, there's x equals 8, so I've got a secant line that, let's say, is right there. So here's f, there's the tangent line, there's the secant line. This is x equals 5, this is x equals 8. X equals 7 is somewhere about there. And you'll notice that the function value at 7 is smaller than the function value on the tangent line and bigger than the function on the secant line. So there's a whole lot of information to sort out, but if you do, it becomes clear what you have to do. Here's a better picture. So, can we find the equation of the line tangent at y equals 5? Well, what do we need to find the equation of a line? We need a point and a slope. How do I find the slope of this? Well, it's the slope of a tangent line, so I would need the first derivative of f at 5, and sure enough, they gave it to me right there. So I know the slope. Do I know this point? Sure, it's 5 comma f of 5, and I can get that off of the table. So I've got a point and a slope. I can find the equation of the tangent line. I can plug in 7 to find out this value, that y value, sure enough, is 4. Now, can I find the equation of the secant line? Yes, because I have 2 points. I have 8f of 8, and I've got 5f of 5 from the table. Notice they gave me 5f of 5 and 8f of 8. So, I can find the equation of the secant line, and if I plug 7 in for x and find the y-coordinate of that point, the point on the secant line, guess what? I get 4/3. And by the picture, you can see, whoops, of course, the function value is in between there, so the function value is smaller than 4 and bigger than 4/3. You can go ahead and read their explanation here. It's twisted, but the picture does a lot. Where do the points hang out here? Well, you get a point for figuring out what the tangent line is, the equation of the tangent line. You get a point for figuring out the equation of the secant line. And then these 2 points right here are sort of arguments that this picture is valid. Okay, that was a lot, but part A should be pretty easy. Part B, you should be able to do with some thinking. How do you find a definite integral? You need an antiderivative, then the rules for antiderivatives, difference, and multiplying by a constant. Part C, we should have done that enough. So long as you recognize what a left Riemann sum is, that should be really just setting up and some arithmetic. So, you don't get all the parts for part D. You still did okay in terms of score. So that's the solution for E5. Thanks.